In section 3.3, we're going to talk about dividing polynomials and the factor theorem. It says here, any polynomial function f of x may be written as f of x is equal to d of x times q of x plus r of x, where d is the divisor, q is the quotient, and r is the remainder. We're going to be able to do polynomial division ultimately in two different ways, but we're going to start with long division with polynomials. Now, before we jump into long division with polynomials, let's consider, like, say, 324 divided by 15, just some numbers. And how we would do that with long division. We write 15 here, that's our divisor, into 324. And we go, how many times does 15 divide into 32? And that would be 2 times 15 to get 30. We subtract the 30 from the 32 to have 2, and then we bring down the 4. And then we do the same thing again. 15 goes into 24 one time, and we subtract that from 24 to have 9. 9 is what we refer to as the remainder from our division process. Other components on the top here, the 21 is referred to as the quotient. The 324 is called the dividend, and the 15, the number we divide by, is called the divisor. So we're going to do the same type of stuff that we just did here with numbers, but with polynomials. So here's what it's going to look like with polynomial division. When we write our result of polynomial division, we're going to be dividing things like, say, f of x over d of x, or we might write it with the division symbol, f of x divided by d of x, where f and d are polynomial functions. And so the result of polynomial division will be written as q of x plus r of x over d of x, where q, again, stands for the quotient from our division, r of x stands for the remainder, and d of x is the divisor. So the first one I'm going to look at here is 4x squared minus 8x plus 6 divided by 2x minus 1. In long polynomial division, we'll start by writing our divisor here, and then what we're dividing into next to that, like so. And then we start looking at how we do division. And to do this with polynomials, we look at the leading terms, the terms that are coming in front here. We ask ourselves, 2x times something to get 4x squared. So what do we have to multiply 2x times blank to get 4x squared? That would be 2x. So we write 2x up here in our quotient. And then we take that and we multiply it to the 2x and the negative 1 to get 4x squared minus 2x. Now in long division, ultimately at this step we subtract, but what I like to tell people to do, and this basically is subtraction if we do it this way, is to flip the signs and combine terms together. So by that I mean change this to a negative 4x squared, change this to a positive 2x, and combine terms. The negative 4x squared and the positive 4x squared add up to 0. So they basically will go away here. And then we're going to have positive 2 and negative 8 going together to get negative 6x. Then we bring down the plus 6 at the end. We do the process over again. We ask ourselves, 2x times blank equals negative 6x. What would that be? What would we have to multiply by? To fill in the blank here, negative 3. Multiply times negative 3 to get negative 6x. Then what's going to happen is that negative 3 it's itself going to multiply to both the 2x and the negative 1 as well. So ultimately, these things up here in the quotient are multiplying to both things. Okay, so now we did the 2x, let's do the negative 3. And we multiply by negative 3, it's going to look like negative 6x plus 3. Let's flip the signs to a plus and flip that to a minus and combine the terms together. Positive 6, negative 6x add up to 0, so it's gone. Negative 3 and positive 6 will go together to get positive 3 here at the end. So that gives us our quotient of 2x minus 3 and remainder of 3. We'll write down our answer here as quotient, 2x minus 3, plus the remainder 3 over the divisor, 2x minus 1. Here we're looking at x to the fourth minus 4x squared plus 6x all over x minus 4. Okay, and we're going to do the long division process for this. Let's start out with our divisor, x minus 4, divided into everything on top, which starts with x to the fourth. But before I go any further, I want to point out how there's an x to the fourth and there's an x squared, but there's no x to the third term. For long division, we need some form of at least a placeholder for all the powers of x descending from the largest one to the very end of the polynomial. So between 4 and 2, we need the power of 3 in there. To set this up then, we're going to use a placeholder for that missing term. The placeholder would be written as 0x to the third. So inside my division, I'm going to write x to the fourth, then 0x to the third, followed by minus 4x squared plus 6x, but I also need to put a placeholder for the number at the very end as well, so we need to put a plus 0 there. Now we have everything the way we need to get started. Like the last one, we look at the leading terms and ask ourselves, how do we multiply to get x times blank to get x to the fourth? That would be x to the third. So up here in the quotient, I write x to the third. That multiplies to the x and to the negative 4. To get x to the fourth minus 4x to the third. We flip the signs to a negative and a positive. Negative x, positive x to the fourth is gone, and we'll have 4x to the third. We bring down the next term, and we do this again. The leading term of 4x to the third. We have to figure out x times blank to get 4x to the third. In that case, that would be 4x squared. So up here we're going to put plus 4x squared. 4x squared will multiply to the x to get 4x to the third. It multiplies to the negative 4 to get negative 16x squared. We'll flip the signs and combine terms. The first term will cancel out, leaving us with a positive 16 and a negative 4 to get 12x squared. Bring down the next term, 6x. We'll ask ourselves, what do we have to multiply again? So we have to say x times blank is 12x squared. That would be 12x. So up here we'll put plus 12x. And then we'll multiply again to get 12x squared minus, then negative 4 times 12 is negative 48x. Flip the signs, combine the terms together. The result would be to have 54x. But we're not quite done because I put that placeholder of 0. We go ahead and bring that down and ask ourselves, x times blank equals 54x. That would be 54. So up here on top, we put plus 54. That multiplies to 54x minus 216. So we'll flip the signs one more time. The negative positive 54 is gone. And we're going to have at the very end here is positive 216. That's our remainder. So what this means for us is how we're going to write our answer is x to the third plus 4x squared plus 12x plus 54, the quotient, plus the remainder 216 over the divisor x minus 4. Now, wouldn't it be nice if there was a shorter way of doing polynomial division than what we've just seen? And there actually is. It's referred to as synthetic division. Now, synthetic division is limited in how we can use it. It's only for dividing by divisors of x plus c or x minus c. But it does turn out that a lot of the ones we're going to be needing to work with, we can actually use synthetic division like 90% of the time. Let's look at some examples where we can use synthetic division. So for instance, 3x squared minus 2x plus 5, all divided by x minus 3. How we go about using synthetic division. So notice how the divisor underneath is just x minus 3. That's the ideal situation for synthetic division. We couldn't do it with anything else than x plus minus a number. So how we set up for synthetic division is we start off by taking our divisor and setting that equal to 0. So that'll be the x minus 3. I like to do that because I treat it like I'm solving. So I would add the 3 over to make it a positive 3. And we're going to use positive 3 as the divisor here basically for synthetic division. And we start off by writing 3 here, where we usually put our divisor in long division. And then we're going to take just the numbers from on top. The 3, the negative 2, and the 5, what we're dividing into. None of the x's, just the numbers. We're going to write that down next to our divisor of 3. So this is how we start with synthetic division. The process of synthetic division, we start by dropping down the first number straight down. So we bring that 3 down straight away. Then we take our divisor number of 3 and we multiply it times the other number down below. So if we multiply 3 times 3, we get 9. That becomes the next number we write over. So with the negative 2, we write underneath it 9. And then we add that number together. So we take negative 2 plus 9, and that adds up to 7. Then what we're going to do is we're going to multiply again to the 7. So if we do 7 times 3, we'll get 21. And we add the 21 and the 5 to get 26. And that's where we stop, because we don't have any other numbers past that, past the 5 up above. So we have a 3, a 7, and a 26. What that tells me is that last number here, the 26, that's the remainder. The other numbers, 3 and 7, are telling me the quotient. So now we know what the numbers need to be for the quotient and the remainder. Here's how we write the quotient. 3x plus 7. Now you might wonder, how do I know it's 3x plus 7 here? Well, a couple ways. First off, we started with a function we divided into has x to the second power. Whenever we do synthetic division, we always lose 1 power from where we start. So from x squared, we go down to just regular x. Another way of telling the difference is we only have 2 numbers in our quotient, 3 and 7. The 7, the last number, is always going to be just a constant, no x. Then that means we only have enough numbers to have 3x and then plus 7, because we always go in descending order of powers of x. So we only have enough numbers to have a 3x in our quotient. Now if we have more numbers, we get more powers of x. So like if we had an extra number, we would have a number for x squared, and then more numbers might have higher powers of x from there. So what that tells us is our answer here for the long division of our polynomials goes quotient 3x plus 7 plus the remainder 26 over the divisor x minus 3. Now the next one we have 6x to the 5th minus 2x to the 3rd plus 4x squared minus 3x plus 1 divided by x minus 2. We're going to use synthetic division here. So like the last time, let's start by taking our divisor, setting it equal to 0, so x minus 2. That again forces me to treat it like I'm solving, so I'll add the 2 over to get positive 2. That'll be my divisor for synthetic division. Then let's look at the numbers from what we're dividing into. We have a 6 here, but there's another thing we need to pay attention to, and that's the powers of x. Notice how they go from 5 to 3 with no x to the 4 in the middle. Earlier we talked about how we need to put a placeholder if a power of x is not there. So we'll consider a 0x to the 4th coming in between. And then we'll have -2, 4, -3, and 1. So that's what we're going to write here. 6, 0, -2, 4, -3, and 1. And that's how we start setting up our synthetic division process here. Okay, what was the first thing that we did in the synthetic division process on the last example? The first thing we did was we dropped down the first number. So that 6 goes straight down. And then we take our number 2 and we multiply it to the 6. 6 times 2, we'll write down 12. We'll add that with 0 and have 12. We'll multiply the 2 and the 12 to get 24. We'll add the 24 and the -2 to get 22. If you see how things are going and if you want to practice it, you may want to pause the video, see if you can go through the rest of the numbers and what you get in the end. I'll multiply again, 2 times 22 to get 44. Add that with the 4 to get 48. 48 times 2 is 96. 96 and -3 add to get 93. 2 times 93 is 186, and 186 and 1 will have 187 here at the end. That again is the remainder. The other numbers refer to the quotient. So if we write these numbers out with their terms that go with it, we started with x to the 5th and what we had to divide into to get started. So in our quotient will drop down 1 power from x to the 5th to x to the 4th. So 6x to the 4th plus 12x third plus 22x squared plus 48x plus 93. That's our quotient. Notice how we have enough numbers to go 4, 3, 2, 1 for our powers of x. And the 93 is the last number in the quotient. Then we write down plus 187, the remainder, over x minus 2. That would be our full answer for this one.